Friends, good evening. Online students, am I audible? Okay, come in. So, totally went out of Hyderabad, underground. Only sincere students came. Okay, students, tomorrow there is a workshop is there. I put that link I put up. There I put it after the class. I'll keep the link, same link, same link will be there. Try to join it. So tomorrow I will speak about some extra programs other than our class. Okay, try to attend the session. 7 a.m. only. 7 a.m. only will start. So last session, what we understood, what we started with. Come on. So we started with thread profile, thread library, thread class methods. How many functions are there in thread class? Thread of target comma arcs, set name, get name, start function, next. Well, that's all. So module name for development of thread based. So we did done that. Aniket, sorry sir, I'm in travels. I'm in travels. That's why I'm unable to join tomorrow. No problem, not traveling. Also, mobile contain internet now. You can join through. So where are you going, Aniket? Huh? Aniket, where are you going? Ma? Function. Pune. You are going to Pune. Okay. So see your comfortability and try to join it. Okay. So current thread, active count. These are the things we are having. And we'll go for one more example, students. Open the notes. Multiple threads I will create. Multiple threads. Write a Python program. Write a Python program which will generate even numbers and odd numbers separately, even numbers and odd numbers separately, even numbers and odd numbers separately by using multiple threads, by using multiple threads, by using multiple threads, by using multiple threads. So let us go for how to use this multiple threads. So two logics are required here. One is even number generation, one more is odd number generation. Program for generating even and odd numbers, even and odd numbers separately by two threads. So earlier example contains how many threads? Only one thread we used it. Today we are using two threads. Two threads means definitely how many functions? Two functions. One thread, one function. One thread, one function. Tell me, function for odd, function for even. DEF, odd numbers is my function name. N you are passing there. Now you are saying that, what are you doing? Printing the result. What is that? Print of. You are printing that, writing this thread name. What is this now? Thread name you are printing. You are saying which input is which input? Invalid input. Dot format of what? Threading dot current underscore thread dot what? Name, comma what? N. I am writing it. This I will write it here. Come in, mom. If n less than or equal to 0, this is a scenario. N less than or equal to 0, written. And we write what here? Else. And I want to print it. So for I in for I in range of 2. What numbers means what? 1 comma n plus 1 comma 2 I will write it. Same logics with the syntax of this. I will print it. I'll print it. Thread name I will print it. And a value also I will print it. What I will print it, you know, odd number. Odd number. Odd number I will print it. Dot format of same thing. I'll write it. Threading dot current thread dot name. Thread dot name. Comma what? I. Good. I'll write it. Time dot sleep off. Just to see the clarity in the output purpose of 1 second, I will write it. This is about what? Odd numbers. Similarly, I'll go for what now, students? Even numbers, I will take it. DE of even numbers, I am going to write it. Even numbers, N I am writing. Invalid input. What is this now? 2 onwards, I'll start. 2 onwards, I'll start. 2, 4 like that. What is this now? Even number. Even number. Threading dot I value, I am going to write it. This is called 2 functions. One function for this, one more function for this. Now I am writing main program. Now I am writing main program. Come on. Create how many threads? 2 threads. So T1 is equal to threading dot thread of target is equal to I say what is that? Odd numbers. This function name I will write it. This function name I will write it. Comma args is equal to, I can say, if you follow me directly, can I write? Actually, here I need to pass the value called 10 comma. I need to write 10 comma. Close the bracket of that. But here I will write what? Dynamic input I will take it. Int of input of like this. I will write. Close the bracket of this and I wrote it. Okay. Enter. Enter. What is this now? How many even numbers? Even odd. Yeah. Odd numbers. Even numbers. Odd numbers you want. Right? Odd numbers you want to generate. Odd numbers you want to generate. If you want, you can write generate. Generate. Return. So args is equal to, see, check the bracket, students, once. Check your brackets. So here, I hope you are following me. One more bracket up. One more bracket. Yes. So here it is 3 brackets and 1 closing bracket of the beginning, right? Next, I'll take up this return. Similarly, I will take it what now, students? Even numbers also I will write it. Even numbers also I want to write it. So I will write it T2 is equal to student. What is my function name? Even numbers, right? Even numbers. Now I am taking now args is equal to how many even numbers you want to generate. So now I will write it. Even numbers you want to, how many even numbers you want to generate it. So that bracket and everything you can take it. Okay, now? So let us start running this example. Okay, and don't think that this is coming to this place, or if you want even numbers, you can take like this. Odd numbers, you can take like this, so that you can see in the same line. Even numbers, you can take. Odd numbers, you can take. Okay, now? Odd numbers, NUMS. So NUMS. Okay. Now I will dispatch the threads or not? Create subthreads. Create subthreads. Okay. Now I'll go for what? Dispatch the subthreads. Dispatch the subthreads. How do you dispatch the subthreads? T1 dot start, T2 dot start, T2 dot start, T1 dot start and T2 dot start. So just run this code. Now I am writing multiple, or I can write even odd threads example 1.py. So both of them start. Dear students, no need to join students because I am not going to print any timing or nothing now. No need to join. If at all you want to print the status and everything, I can go for writing joining. Okay, now? Right. So execute it. Go to this place. Import, yes. Import threading. And what next? Time. You execute it, guys. And go to this place. Go to this place. D column. So go to this place. Here we are. Python here. 6 p.m. Say here, threads. There I will take up py. Now see this now. Enter how many odd numbers you want. 10. How many even numbers you want? 10. So it is going to give you the data. And don't think that they are going to come in a mismatching order is not following. Don't worry about it. Because even numbers it is displayed somewhere. Odd numbers will be displayed somewhere. Are you following? Thread 1, thread 2 like this. If you run it once again, don't expect same output will come. Maybe changing. So here 10, here 20. Here 10 and 20. So 10, 20 will come for what? 10 times only odd numbers will come. Later what will come only? Even numbers only will come. I hope you are following that. You see here 20, you say 10 here, you'll be getting like that. See students, you are getting like this. And now what is continued? Odd numbers are continued. Getting up? So this is a scenario of what? Multiple threads. With this, what did you understand? One thread and one resource. And a one T1, what is the function name? Odd NUMS. NUMS. It is called what? Resource. Resource is nothing but an object. Every function is called one object only now. T2, what is the next one? Even NUMS. Even NUMS. What is T2? Object. What is even NUMS? It is the object. 1:1. One thread, one function. This is known as what? 1:1. It is nothing but multiple threads. T1, one function. T2, one function. T3, one function. Each function is running in their own way. There is no interference in these threads. So we are getting result here, result here, result here. Even though I have multiple threads, each thread is running its own function. So there is no interference in that. There is no collision in that output. This result is called what students? Thread safety result we can call. Spell out. Thread safety result. What is meant by safety? Correctness of the result is called what? Thread safety. This result is called thread safety. What is the thread safety result? Even though I start multiple threads are entering into multiple functions. So 1:1 execution parallelly going on. What is that is known as? Thread safety result. What is the formula here? One thread, one function. One thread, one function. Understand students? So we are going to, this is by using what mechanism? Functional mechanism. Through object-oriented mechanism, I want to show you one more example. Through whoops, I can show you. Through whoops, I can show you. Look at that. Just it is a matter of adding. You already know that class. What is this now? Numbers. If you want, both of them you can place in the same way. Both of them you are writing in the same class. What are you doing? Tell me. Self comma. Next is called what here? Self comma. Okay. What are you doing now? Come to this place. What are you doing? Tell me. Numbers of. Beautiful. Numbers of dot. What is this next? Numbers of dot. That's all. Same to same. See what just one change is there. What is this now? 2.py. With whoops this is. Even odd thread example 2.py. Go to this like example and see this now. See this now students. Py 2 dot. How many numbers you want? 5. How many you want? 5. You'll be getting the result like this. Are you following me? Now you say 1 is 10 and one more is 15. You'll be getting the number something like this. So here the result is going to be like this. And the rest of the numbers are coming only from that. Getting up? So this is about what? OOPS related. Whether it is a functional programming or object-oriented programming, it depends on how you write it. Just I changed it into OOPS level. Getting up? So OOPS level is lightweight application or functional level is lightweight application. OOPS is lightweight because object-oriented programming provides what? For every function, if you take it, there is a memory space is taken. When you go to polymorphism kind of thing, one function can do many operations. It is simply called as what? Lightweight component it is going to become. In the beginning days, I said, both functional and object-oriented, I said. Functional applications, good. But compared to object-oriented, functional applications are little heavyweight. So, better to write with what? OOPS-related kind of things. That's why in AI level, as on today, every robotics application, every business apps are coming in the form of what? OOPS level only, right? That's why be perfect in our example students. Now I am going to introduce one more concept. So what is the model here? What did you understand here? Last and final, I am going to say, whatever we have seen these 2 days, this is called a model 1. What I am introducing today, model 2. Thread T1, thread T2, thread T3, thread T4. What is the T1 is having? One function called the X function is there. One more function is called Y function is there. Next, one more function is called Z function is there. One more function is called K function is there. What did you understand with this? Come on. T1 will execute X function, T2 will execute, T3 will execute, and T4 will execute. In their own way, they will parallelly run it. Which result we got it? Thread safety result I got it. Which result, mom? Thread safety result. This is called model number 1. In other words, in a normal level, if you want to understand, there is a person 1, person 2, person 2, person 3, 4 persons are there who are coming for participating in running race. This is a separate runway. This is a separate runway for all the people. Separate runways are there. Each person is having separate runway. Is there any interference in that? No, that is nothing but one person, one runway. One person, one runway. It is a safety running, right or not? It is also one thread, one function. One thread, one function. It is called what? Safety running. Getting my point? But now model is very, very simple. T1 is a thread. T2 is a thread. Second model I am showing to you. T4 is a thread. It is nothing but a person 1, person 2, person 3, person 4, 50 people are there who are ready to participate in the running competition. But the running people who are organizing, they kept in one line only. They instructed everybody must run in the same lane. What they will do? They will try to enter all of them into this runway. What is happening? Just imagine some collision will happen. They may fall down. Some of them may fall down here. In this kind of appearance of entering into the single narrow way, there is a chance of falling down. And that result is called what? Safety or non-safety? Such non-safety results in our programming called what? Deadlock we can call. Which one? Deadlock. Deadlock we can call. In programming, if you come, this T1 is ready to enter into the function. Only one function is written, guys. DEF, only one function. I'll show the example also, ma. 1 minute you wait. T1, T2, T3, T4. All the threads are targeted to which function only? X function. All of them are enter into which function? What will be the result? Can you expect which result will come out of that? You can't expect it. Some collision will occur internally. Some type of operation will take place. No programmer can predict the result of this X function. Why? All of them are entering into which function? X function. That result is not predictable by the programmer. That is known as what? Non-thread safety result. Non-thread safety result. I'll show the example. Non-thread safety result. It non-thread safety result definitely will give you which result? Wrong result. In operating system point of view, we call it as a deadlock, we can call. Deadlock occurrence will give you what result compulsory? Wrong result. So work is done. That work is done and gives you which result? Wrong result. In your colleges, your faculties given a normal textbook example. What is the textbook example? Process P1, process P2, two processors are available. There is a resource R1, there is a resource R2, there is a resource R1. If the program P1 want to complete its execution, how many resources it need? Two resources it need. This is a food, this is a water. This is a water. Two friends are available. Both the friends require food, both the friends require water. And I start. What happens? Friend 1, process P1, hold the water bottle and requesting for the food. Meantime, the food was held by whom? And P2 is waiting for what? Water bottle is already held with whom? And waiting for what? Food is held with whom? So P1 is not releasing the water bottle, P2 is not releasing the food. What is happening? Both of them are waiting for each other. At least they are not coming to a mutual exclusion. Combined together, we will eat. Both of them are waiting for each other. No work is done here. No work is done. It is also called as what? Deadlock. Are you following me? This example don't tell. Practical example you need to introduce. Shall I write one example now? Model 1 says what? One thread, one function. Here, multiple threads, one function. That is 1:many ratio is giving you deadlock. Now I am going to give you students one small example. Let me go to that. Let me go to one small projection I will give you. Here, there is a thread T1, ma'am. There is a thread T1. Thread T1 want to T1, T2 and T3 and T3, T4. 4 threads are there. Both of this thread T1 decided to generate. Okay, I will take like this first. DEF MUL table. MUL table of what? N. N. Be careful, mom. And I am writing the multiplication table logic is written. Multiplication table logic is written. Multiplication table logic is written. Now, T1 is decided to execute what? 10th. Next is called what? 14. Next is called what? 16. Next is called what? Here 25. T1 want to generate the multiplication number for what? 10. Done. T2 want to decide for what? MUL. T3 for this. T4 for this. Are you able to follow? So both all of them are entering into where? Can you predict which multiplication table will come? You cannot predict it. All of them are coming into the same place only. All of them are coming into the same place only. Finally, what is the result is coming? What is the result is coming? Deadlock result will come. No safety result will come. Can you predict it? Which result? No. What is that result is called? Deadlock. That is called wrong result will come. Wrong result of multiple threads execution is called deadlock. Let me show you the code for that. Let me write the code. Now, program for, here I will write it. Let me close this. Now I'll go to the place. Others. Now I'm writing program for demonstrating multiple threads enters into same function and raises what? Deadlock. In another word of operating system, race condition we can call. What is that? Race condition. Look at how easy. DEF MUL table of N. I am writing there, if n less than or equal to 0, I'll print here thread name I will print. I'll say what here is invalid input. Dot format of what? I'll write this sentence now, students. So here I will write it. Dot name of what I can write? N. Now I'm writing now else. What should I write in else? Tell me. Thread. Current thread dot name N I wrote it. It is invalid input. Else. What should I write it? Come on. Print of multiplication table. Multiplication table. I say multiplication table for, I write it, format of, what is that? N is coming. N is coming. Now I want to print the result. What is that now? And that I will print the thread name also here. Thread name. Which thread is printing what multiplication table? That also I will write it. Of course. Carefully follow, students. Now I'll write the logic. How do you write? I'll just write it, some small line where you can get it. Now I'm getting like this. So say, tell me now what I'm writing now. For I in a range of 1, 11 for print of, come on, print of backslash t into is equal to, I'll write it, dot format of n comma I comma n into I. N into I. That's all. And I will make it to go forward. Time dot sleep of 1. Just for a minute of it. So I'll import it as usual. Import threading comma time. Threading comma time. So I'm going to enter into the main program. Main program I'm going to take up. What is my main program? Carefully observe it. T1 is equal to create multiple subthreads. Create multiple subthreads. Multiple subthreads. How do I do that, students? Threading dot thread of target is equal to what is this? MUL table. MUL table. MUL table. Comma what? Arcs is equal to. Come on. I will pass it. 10th table I want. 10th multiplication table T1 want. Right or not? Right. Now, if you want, you can read also from the keyboard. I will take it 12th multiplication table. 12th multiplication table T2. Which function? Same function. Earlier we mentioned what here? Odd numbers or even numbers. Separate. But here what? Same function. Right? Next I will take it. Another one. T3 is equal to. Now I am writing something like a 9th table. T4. Last and final I will take it. 19th table. T4 is equal to how many threads? How many functions? That is many to one. Many threads in one function. It gives you what? Deadlock result. You will watch it. Dispatch the threads, students. Dispatch the threads. Dispatch the threads. How do you do it? T1 dot start, T2 dot start, T2 dot start, and a T3 dot start, and a T4 dot start, T4 dot start. Are you following? When you say start, it is going to enter all of them into the same function. And see that this mechanism, deadlock result is nothing but what? To eliminate this deadlock is nothing. A person is going on the way and then what? Speaking in cell phone, watching this side, that side, without doing the actual work, is unnecessarily creating multiple threads to enter into the same riding. That will give you what? Deadlock result. Unavoidable situations will expect it. That's nothing but he has to make his brain as synchronization. What is meant by synchronization? Concentrating on the work what you are doing. So this mechanism of getting deadlock is called deadlock occurrence is there. To avoid that, we will apply which concept? Synchronization I will apply. Synchronization mechanism avoids what? What is synchronization? Allowing one thread at a time to do the operation. Once one thread is over, allow another thread. This example, I'll keep the word as what? non-synchronization functional example1.py. Non-synchronization example1.py or deadlock occurrence example1.py. Getting students? Right? Seema, target. Yes, Sushma. Sushma, who is that? Ganesh. Target. Sir, target. We can take as global keyword. It's possible. My dear student, it is called what? One sort of keyword argument it is. It is a keyword argument. It is not a keyword. It is a keyword argument. Because already you know, it is a formal parameter inside of each one constructor called thread. You have to write as it is. Ganesh, I hope you understand, my dear student. So it is a keyword arguments. Already in functions level, we discussed that. Execute now, students. Go to the place to see that py. Careful. You see the result, how it is coming. Observe it. You can't predict the output of it. See that what is the result is coming. 4 threads are there. What is happening? Which thread is happening? What you cannot predict at all. You cannot predict at all. Finally, it is finished. See the result of it. Which thread is started? Thread 1. 10th table. 1 line come. Immediately thread 2 interfered. What is that? 12. Thread 3 also interfering. Thread 4 also interfering. What is happening? 12 into 1, 9 into 1, 19 into 1. 10 into 2. Already 10 into 1. Now 10 into 2 continued. 9 into 1, 9 into 2. 19 into 1, 19 into 2. 12 into 1, 12 into 2. Whose result is, to whom this result is useful? Is this result is useful to anybody? No, not at all. This result is called what? Non-safety. Non-safety result. Did you understand? This is called what situation? Deadlock situation. Work is done. Which result? Wrong result. To avoid that, we'll go for what? Synchronization. So, go to that. Online students, did you understand this mechanism? Did you understand this mechanism, students? Everybody, now. This is by using functional. Let me show you by using object-oriented also. Object-oriented also, I will show you, students. See this. It's quite easy for you. I will write it. Class. What is this now? Table of. Table. I will write it. So I will use it. There I am writing. Self, I am writing it. Self, comma. Self, comma, I am writing. Self. Now coming to this place, how do I write it? How do I write, ma'am? Table of. Table of. Dot. What I am writing now? Table of. Dot. Next is called what? Table of. Table of. Dot. Again I am writing here. Table of. Dot. Getting? All of them are entering into same class object, same function name. Also give you the same result. This is called what? Oops. Example1.py. Non-synchronization only. Deadlock only. Deadlock only. Execute it. Same to same. Same to same result will come. Same to same result. All of them are interfering into the same result. Finally, no more results are useful. Such results is called what, you know? Deadlock result. How to avoid that? We will go for synchronization. Synchronization mechanism eliminates what? Deadlock result. Okay, now? Let's start the deadlock result. How easy it is, students? Go to the class. There is a class is available. What is the class name, students? Lock. How this locking mechanism? How many threads are there? 4. Think carefully. You want to enter into this room. All 4 people are coming at a time to do the operation. What will happen? A wrong result will come. What is this mechanism says? Deadlocking I am using. All 4 are coming. I am standing there. Whoever comes first, which I observe, that person is allowed inside. And keeping the back bolt, that is called what? Locking the door. And other 3 are waiting outside until the inner person comes out of it by unlocking the bolt. Me, as a PVM, I will see that it is unlocked or not. If it is unlocking, second thread will be entered inside and keeping the back bolt and then doing the operation, finishing, unlock it, come in. Third person also lock it, do the operation, unlock it. Locking, unlocking, locking, unlocking will be continued until who will complete? All threads will complete. So keeping the back bolt means what? Lock object. That means lock object you will create. L is equal to what you will do? Create an object of what class? Create an object of which class? Lock class. Bolt is one only. You are going to acquire the lock, releasing the lock. Acquiring means getting. Releasing means coming out of it. Create an object of what? Lock. Lock is one or many? One only. Once you enter inside, you do what? Acquire. Acquire means get it. Once you get it, others will be made wait simply. Until you do the operation by yourself, do the operation by yourself, do the operation by yourself, and do what? Come on. Release. L dot what? Release. When do you release? Once you complete your operation. Are you getting my point? So are you able to get it? So these three steps are required to implement what? This is called synchronization concept using. To implement the synchronization programmatically, I need library or not? Create an object of which class? Lock class. Acquire it and then what? Release. Now you observe the coding. Go to the functional approach. Copy. Go to the program. Everybody observe students, online students. Now see here as usual, same. Here, first time, I'm going to use what? Synchronization. Synchronization. 1 minute. Okay. I'll go for it. There I'm going to say synchronization now. I'm avoiding. Avoids and avoids what? Deadlock or race condition. Synchronization functional part. Here, for all these threads, what is the shareable area here? Which is the shareable code? MUL table code is a shareable or not? This shareability, I should stop it. The best example you imagine, traffic junctions. Traffic junctions you take it. If all vehicles go at the same shareable place, what will happen? Left, right, opposite vehicles are going at the same place. It will happen some unavoidable situation or not? One side vehicles are going on, other vehicles are made wait until this is becoming locking. Red line, green line is called what? Red line says what? Locking. Green line says what? Unlocking. Same here. Lock, acquiring, releasing, release, unlocking. So I will create an object of what? Lock. Here I am writing. Create an object of what class? Lock class. First time. L is equal to threading dot lock off. Threading dot lock off. Creating an object of lock. Yes, created. Global variable. What is happening? T1 dot start, T2 dot start, T3 dot. All of them are entering into the target function or not? Since I started T1 first, definitely with the milliseconds of time, who will enter first into MUL table? T1. The moment when it is enter into T1, it will acquire the lock. L dot, come on. Acquire, Q-U-I-R-E. Spelling you take care. Acquire the lock. This is called step number 2. Where can I write acquire? That is an important. Where I will write it? These are all the statements should not execute by all the threads at the same time. Because of executing all at once, we got the wrong result. That's why I am acquiring before executing. This is called step number 1. 3 steps are required. Understand? After finishing, whether it is a valid number or invalid number, I will write what you know. I will write what? Parallel to this if. I will write parallel to this. I will write what? L dot release of. This is called step number 3. You should not write here. See the indentation. If I write here, what is happening? Only for positive numbers only releasing. For negative number is coming by mistake now. It is coming to what? Only acquiring, you are not releasing. Still that will be waiting there only. Are you getting? So first let me write here. Later I will show the effect of writing with indentation, without indentation. So I'm writing parallel to what? If else. So it is suitable for else part, suitable for if part also. If I write by mistake in this by pressing tab, and if we write there, for positive numbers only it is working, for negative numbers it is not working. Let us work out for all of them. I wrote parallel to that. This you have to observe it. This you have to observe it. Now see that, execute now. See how beautiful output will come. Save this, online students. 3 steps are there. Step 1, step 3. Execute, PY. See that who entered? Thread 1. Thread 2, thread 3 are made wait until who will complete? Thread 1. See the result. After finishing that, thread 2 came. Thread 2 came. Right? Next. Thread 3 will come. Thread 4 will come. Entering, locking. Unlocking, thread 3 entered. PVM is locking, unlocking when based on our code which is written. Now, after finishing that, thread 4 will be coming. That result will be coming. Okay. So after finishing that, I will show you that releasing part. Should be careful enough in understanding that result. Go to this area. By mistake, if you write like this, it's the only beginning you are acquiring. You are writing in the positive side. Go to that 10 and you are writing minus 12. What is happening? Minus 12, 10 you take it. You are acquiring, got it, false. Coming to this place, you released it. Next, who came? Thread 2. Thread 2 is what? Minus 12. Minus 12 means it is called what? Done. And it is coming out of that. It is looking here. Which one? Release. No release. It is waiting only. No thread is allowed. You got that effect? You observe it. You see this now. See that? Thread 1 is okay. Thread 1 is released. Thread 2 answer is coming, but it is not releasing the lock. So see, now it is like that only. What is the meaning there? Thread 2 got the result. F part is executing, but it is not releasing. It is waiting. What is that problem? You are not releasing the lock. Even if press Control C, it is not going to stop the program. Because once you acquire the lock, you have to close the window. Windows prompt, you have to close it. You have to close this crossbar. If you say Control C, breaking also not possible. That much powerful it is. Once you close it, then only. Again, I have to go to the program. That's why you must write very properly. Are you getting this? Releasing and acquiring is very, very important. Go to this command prompt. Go to this place. Now I'm writing Python and say 6 p.m. here and say now threads here. So I'm writing here threads. Now I'm going to write it. PY. Now I'm saying this, getting the result of that. And see this carefully. So minus 12 is invalid input. Thread 3 is there. Why? Releasing is written in the proper place. Right? This is the way how you can understand it. Did you understand this? Similarly, you can go for what? Object-oriented programming also, same mechanism. There is nothing is difficult in this mechanism, student. So I hope that you understand this result. When you go to OOPS level, it is also going to be similar. So see students, in OOPS level, how it is going to be working out. Here I am going to take up. In this place, functional here, I will write what you know. OOPS, I will write it. In this case, you have written arcs is equal to like this, you have written it. What is happening, you see. I will remove this place. Okay, let it be. Keep it. I will write what here? Self, comma. Meantime, I will write what you know? Table of. I wrote it. So, written. What I'll write it? Same as previous. Come on. Table of. I'll write it. T capital of. Table of dot. Here also I'll write what? Table of dot. Here I am writing table of. Next I am writing table of written. Like this it is written. As usually you take it as what you know. Let us increase your fastness of this 25. Now try to run this now. Oops, example 1 dot. See this now. Run this code py. So locking and unlocking will be same. Thread 2 is called invalid input. Thread 3 is coming. Thread 4 is coming. Something like this. Output is like this. If I remove that locking and unlocking, what is an answer? Invalid inputs will come or not? Right? That is deadlock result will come. If you want students, of course, you know that. You see, I'll say in other way I will do it. Try to follow me. This lock is there now. This lock is there, right? Create the lock, not in this way, like functional mechanism. Since lock is a common for all my objects, what I'll do, at the rate class method, you already know this, class method, def, what is this now? Get lock of what? CLS. CLS dot, you write that statement. Get the lock, create a lock. So you see that students, CLS dot L is equal to you this create an object of what class? Lock. CLS dot class level method. Class level method is common or not? How do you call it now? MUL table of how do you call it? Table dot acquire L dot acquire, because it is a class level data member. Class level data member. Here L is what? Class level data member. How do you call class level data members? By using what? Class name. Table dot L dot acquire. Here I am writing what? Table dot L dot release. Releasing the lock. Acquiring the lock. How I am calling? Class name dot. This is by using class level. Example 2.py. So simple. So simple. So out of that 2.py, same result. What is happening? Something is happening. L dot has no attribute. What happens, students? Okay, good. So I did not call that method now. I have to call this or not? I have to call it. Where I will call it? Here. Table dot. What is the function name? Get lock of. Call. Which method? Class level method. Class level method for initiating lock object. For initiating which object? Lock object. Very, very important. See the output of it. Got it. So I did not call that method. That's why L is not found. Now we got the answer. Got it up? Fine. So class level variable. Get it? Now same thing. Of course, these are all ways and means. Once you know coding well, you will do wonder, students. So here I will define, here args is written now. I won't write this. Today I don't write this. Args I don't write this. Here I am not writing. Here I am not writing. What I am doing? Only function. Here I am writing what? 10. Here I am writing minus 12. Here I am writing what? 13. Here I am writing 19. What is this? Constructor. Constructor. How do you write the constructor? DEF. Come on, students. DEF. Underscore init underscore of self comma n. Self dot n is equal to n. There I will write it. I don't write this n. Self dot n is equal to. Self dot n is equal to. Here I will write what, ma? Self dot. Here also I will write self dot. Self dot. N comma. What I am writing? Self dot n comma. Self dot n. Like this I wrote it. Everything is same. Getting my point? Yes. Very, very easy. 3.py. 3 or 2? So here I am going to say 3.py. Synchronization, whoops, example 3.py. See, students, how simple it is. Py output is going to be same. constructor. Whatever value you are passing to that object, same value is getting executed like this. Are you following me? Right, students? Like that, one need to go for writing the code like this. See how many ways? These are all known things only, na? Constructor, class level method, everything. Now I will go to students in online, parameterized constructor, class level method, instance method, acquiring the log. Getting or not? Like that you need to understand. Now I will go to one more kind of example on the synchronization only. Take your railway reservation, bus reservation, you take it, bus reservation. For example, you are belongs to X village, Y village, Z village of the same route only, same route. Here X village, Y village, Z village is there. And this is a bus in Hyderabad, whose service number is called 4396 and seat number 20. And the X person is trying from Amirpet, Y person is trying from something like SR Nagar, and Z person is trying from Mumbai. And who come to Hyderabad, and from this place they want to start the journey, for example. So train reservation, you take it, IRCTC project. So what is this seat number is called? One resource. How many threads are attempting to reserve? Many threads. Each person is making an attempt to reserve it. What resource they are trying? One seat number in one bus. If I don't apply which concept? Synchronization, 3 people get the output. Okay, reserved. One seat, 3 persons reserved. What will happen? So you are already sat in the chair, another person will come. And I was there beside to you, and I will take 3 tickets and I observed it. 11 o'clock, 3 minutes only, everybody was reserved it. They are not maintaining even seconds also. So same time they reserved it. What is happening? So it is the problem of what? Application development. So what they should apply? Synchronization they need to apply. Once you make a request, other people has to be made wait until whether the seat is confirmed or not. If they confirmed it, it is a message going there, it is already reserved. Understand? That type of mechanism is called what? Synchronization. Shall we go for it? So reservation of bus or reservation of that, we'll go for it. Understanding, students? Online students, now I will write that code. Carefully follow now. All of you carefully follow this concept. I'll introduce it. Let us move to the, I'll show you one small concept, students. One small concept I will show you guys. Just try to watch it. Let us watch this now. Concept I'm showing. No. When multiple threading, synchronization in multi-threading, locking concept in threading. When multiple threads are operating or working on same resource, that is either function or method, then by default, we get deadlock result or race condition, wrong result, non-thread safety result. These are the different synonyms of what? Deadlock. To overcome these deadlock problems, we must apply the concept of synchronization. The advantage of synchronization concept is that to avoid the deadlock result and provides a thread safety result. In Python programming, we can obtain synchronization concept by using locking and unlocking concept. Steps for implementing synchronization or steps to avoid deadlock. Create an object of lock class which is present in threading model. Lock object dot threading dot lock. To obtain the lock on the shareable resource, we must use acquire. Wherever you feel that shareability is there, before the shareability you write acquire. After completion you write release, so that no interference will take place. Acquire. Once current object acquire the lock, other threads are made wait until current thread object releases the lock. To unlock the shareable resource or current object, we must use release. Lock object dot release. Once current object releases the lock, other objects are permitted into shareable resource. This process of acquiring and releasing the lock will be continued until all the thread objects completed their execution. It's a concept, simple concept, but coding is wherever you are getting the deadlock, we can apply acquiring and releasing. Shall we? Let us go to the next example. Now I'm going to introduce, take care. Now I'm going to take it, reserving a program for reserving a seat, by using almost you have to do it with threading only, you will do everywhere else. So I'm going to use it threading with what concept? Synchronization. DEF. Look at students. Reservation is my function name. What this reservation function will do? Tell me. It will take what? Seats. So I will take it number of seats, right? Number of seats, which you are passing as a parameter. Just say pass. Coming to main program. In my program, total seats I will take it. Total seats is equal to, so for example, 15 seats are there. Assume that. You can take any number of seats, no issue, but I'm taking 15 or 20. Whatever you like it, you take it. Now, what should I do now, dear students? What should I do? Total seats is equal to 15. What should I do now? I will create the subthreads. Create subthreads. Subthreads are nothing but what? Passengers. Passengers they are called. So many number of threads will be. Any passenger comes, one thread will create internally. So T1 is equal to threading dot thread of what is that? Target is equal to this function name. I will use it. I will write it here. Function name. Comma, what I am doing? Args is equal to, he need 5 seats to reserve. He want 5 seats to reserve. Another thread, T2. He want 6 seats to reserve. 6 seats to reserve, T2. Or he wants 16 seats to reserve. T3 I will take it. This person want to reserve for 6 seats. T4 I will take it. He want to reserve for 5 seats. So this is called 4. And one more person is there. He want to reserve for 1 seat. So T5. Who are successful in reservation? Based on that, T1 is successful. T2 is not successful. T3 is successful. T4 is not successful. T5 is successful. Suppose if you don't take care about that part of it, I will write here 15. If I don't take care about what? Synchronization, everybody is successful only. Are you following that? So how you can do this? Now I am going to write the code. Tell me now. Come on fast. I say if, what is the condition? NOS greater than TOT seats. TOT seats. What is your number of seats? For example, here 25. For example, 25 is present into NOS or not? 25 greater than what? 15. True, na? Sorry. 25 greater than 15. True. False and true. Problem, huh? So want to go to underground? So true. 25. That time what I will do? Print off. I'll print. So I'll write it. Dear passenger. That is nothing but a thread name will print. Dear passenger, seats are not available. Try later. Try next day. Dot format of what? Threading dot. I want to print that name. Current underscore thread. Dot what? Name, comma. NOS. Okay. Right. Done. So the thread 1, dear passenger thread 1 or dear passenger Rosam or something like some student. That 25 seats are not available, try for next day. Suppose now it is what? 5 only. 5 only. 5 greater than 15. Tell me. False means coming to which part? Else part. In the else part, what should I do? I should, since it is there, it is okay. I need to do what? Update my seats or not? How do I do it? TOT seats is equal to TOT seats minus what? NOS. Number of seats. What is the TOT seats? 15. 15 minus how many? 5. How many are there in total seats? 10. That means who reserved it? Reserved or not? I will say, dear passenger, seats are reserved. So I say reserved. So come to that. Happy journey. JRNY. Just a small happy journey. So I'm saying that happy journey or. So I written it and printing that and then getting. After that, now I will write a time dot to sleep of 1 second. Immediately I will print now available seats. I am printing the status. Now available seats. Now available seats in train. For example, I am saying I will write it dot format of what is that? TOT seats. TOT seats. This is one status, student. This is one status. Okay, done. And see, students, will it execute or any error? Error. Global of is required. We are modifying. I will write here. What should I say? Global. What is that? TOT seats. Referred in the beginning. These kind of status to be continued. This type of status to be continued. This type of status to be continued. 1 minute. Here, global seats is written. This is the status of one person. This is the status of one person. Okay. And here what I will do? Here how many people will do at a time? All of them should not come. Only one person should come at a time. What should I do to implement this? I should say, go for creating log update or not. L is equal to, take your own variable, no issue. Take your own variable. K is equal to, tell me, threading dot, lock off. It is called step number 1 or not? Step number 1. What should I do now? K dot acquire off. K dot acquire off. K dot acquire off. What I am doing now? K dot release off. K dot what? Release off. K dot release off. Simple. Shall I execute now? Yes. This is called step number 2. Step number 2. This is called step number 3. Step number 3. Who are permitted, who are not permitted, you will see that carefully. And if you want to say here, students, T1 dot name is equal to Rajesh. T2 dot name is equal to Naresh. And T3 dot name is equal to Vinay. So Vinay, I am writing. Next T3 dot T4 dot name is equal to what do you know? So something like Naveen. Next I am writing something like T5 dot name is equal to what something like Rakesh. These are the people who are there. So I'm giving my own names to the threads. Import what threading comma what threading comma time, comma time. So comma time. Now I will write it, students. I'll say, so here reservation, functional example, something like synchronization SYNC, example1.py, example1.py. Save it. Go to the place, threads. No? Yes, starting the threads is important. Dispatch the threads. Dispatch the threads. Dispatch the subthreads. T1.start START. Start and T2.start and T3.start, all the things you started. T2 dot. Next T3 dot. And T4 dot. T4 dot. T5 dot. T5 dot start. Done. Okay. Execute it, students. Go to this place. PY. Say this example, 1 minute. I say this example, getting this. So here I'll write it. And before that, I would like to mention one small point. Print of what? I'm writing here. Initial total number of seats. Total number of seats is equal to, comma, what is this now? TOT seats. Just a beginning I wrote it. PY, see that total number of seats. See that it is going to give you the result. You did not find the result properly. So I will make this as some sleep state more. 5. Because you are not able to see, because you are in sleeping mode. I know that. Total number of seats. Dear passenger Rajesh, 5 seats are reserved. Happy journey. Total number of seats in train is 10. 10 minus 5. Dear passenger Naresh, 15 seats are not available. Try again. Dear passenger Vinay, 6 seats are reserved. Done. What, students? Still you did not see. So, are you seeing? Now see. Seats. 5 seats, okay. Now are called what? 10 only available. Naresh did not get it because 15 is exceeding. Next day, sleeping. 6, Vinay got the 6 seats. Next, how many are there? 4 only. Now 5 seats not available for Naveen. Next, 1 seat is reserved. Now, available seats will be 3. Are you following? This is the way you can simply write it like this. Any real-time requirement is coming. You need not to feel any tension at all. If you put your subject now, you can happily write the code. There is no unsolvable things will not come. And if you take 10 members team, and I'm telling to you as on today, almost you can take half of the people don't know coding. The rest of the people only, in the rest only 1 or 2 candidates will be jumps are there. Jumps in the sense they can solve anything. The rest of them are like in the queue only, like a compartments in the train. 1 engine is there, total compartments will be there. Even if you take 3-4 days leave also, no problem for you. They will give you. If you don't know coding, if you take a leave, they will take you something. And you will not take leave also because you have weakness. And don't think that you have weakness. You have to do well in the coding part. Are you following me? Right. So, coming to the point back. So, in the companies I am saying, you may ask, sir, why are you not taking leave? If I take leave, when my students will learn? Education is different. That is different. Are you following me? Right. So, come to the point back. This is about what? With functional programming. With functional programming. So, here if I say something like 4, if I say 4, the last and finally you execute. So, you are going to get it. All the seats will be reserved. Total number of seats are how many? 0. I hope. So, next is 4 seats reserved. And next is called another person is 4. 0. Number of trains and seats is 0 like this. The same example you can write with what also? Functional programming you can write it. Object-oriented programming you can write it. And I need not to show you everything. You can write like this, students. So I am writing here class train, class train. So T-R-A, train. So there I will write it, students. In this place, I am saying this part. Here I am writing like this. I say here, what is this? Self. You can write self. Number of seats you can write. And you can take constructor and everything like my previous example. Class level variable you can take. Happily you can take it. What is this now? Train off. Train off. I need to write a train off. Every moment I need to write a train off. I need to write a train off. And I need to write a train off. And I need to write a train off. Are you following me? Execute it. Execute it with a functional. This is called what? Object oriented programming. OOP. So here you go for it. So there it is going to be available. Threads here. Go to this place. Execute it. So execute now. See, the same answer will come. Everything is same. Are you able to follow? Right. So this is how the object oriented or normal coding, locking, acquiring, and then releasing the lock. Get it out? Any difficulty? No. So you have given some money to one person and that person went to London. Jumbo. All the Indian banks are giving money to some people. They are going out of that. In London, one person is there. You know that person name. And he came to Hyderabad and you met him. You also gave 1,000 rupees, 2,000 rupees, 5,000 like that. He is giving check for everybody. But his account is having only 5,000 rupees. He has given such checks to hundreds of people. And he cannot check immediately now his account. Next day you will go to bank. All people put the checks. And the checks will go to his account. One check is cleared, other check bounce, check bounce, check bounce. How it will come? Synchronization mechanism. Understand? One account, multiple customers. What is that concept? Shareability. One is to many. What is that concept? Synchronization. Who is that person? Went out to London by taking. Indian banks are under, some banks are under loss. Why? They're keeping these customer charges to recover that. So that's why when we go to banks now, as a software engineer, they will ask, bring your pay slip, 6 months pay slip, that pay slip, this pay. That person comes now, okay, take and go. Crores of rupees, politicians. Now I'll go to, following me, go to the next example. Go to the place, next example. Do you know who is that person went out to, we should not tell out? You know that. Oh, that person. So let us go to that. Yes, ma. Ganesh. Exactly. Exactly. He is participating in London elections with Indian currency. Maybe we don't know. Okay, let it be. Shall we write that? Now, let us write the example. We go for that. Now I'll write the example. Last example with the threading. It is important. So how this multiple synchronization once again. Come on. What is this now? Program for withdrawing the amount from which account? Same account by multiple customers. Multiple customers are nothing but what? Multiple threads. Same account means what? One to many. Which concept? Threads. Come on. Now go to the place. Class bank transactions. DEF underscore init self dot W amount. What I am going to write it? I will write it self dot W amount is equal to AMT at the rate class method DEF get a ACC balance. Get a ACC balance. CLS dot ACC bal is equal to something like 20,000. Are you following? So next I will go for what? DEF withdraw. DEF withdraw. What are you passing? Self comma. What is this? What is your amount? Of course, you are passing the withdraw amount there. Need not to pass it. I say pass. For a minute, you come to main program. Main program. First, you initialize your bank account. How do you write it? Bank transaction dot. What is this now? Get balance. Dot what? Get balance. What are you printing now? You are writing here. What is this now? Initial balance. Initial account balance. Initial account balance. Initial account balance. Dot format of CLS dot ACC balance. ACC balance. Okay. Take care. And this is just printed like. Okay. This is done. Initially showing this data. Come to the point of it. Who is that? Create multiple threads. Multiple threads are nothing but what? Multiple customers. Customers here. Very simple. Come on here, guys. T1 is equal to threading dot. I'll go to this previous place. I'll take these people, students. I'll write it here. Write it. Multiple threads, customers. T1 dot. What should I write it? Bank transaction dot. What is my function name? Withdraw. I'll write withdraw. Here, I don't pass any such type of thing. I will just pass it. He want to get it. So 1,000 rupees. So is right? Rajesh is trying to withdraw what? 1,000 rupees. Okay. So this is called constructor calling or not? See guys, constructor calling. That amount is going to be withdrawn. Similarly, I will go for what now? Another thread I will go to it. There I will write it. He is having what 4,000. Next, another person is there. He want to get it 12,000. Another person is there. He want to get it 4,000. Another person is there. He want to get it something like 3,000. So here total amount is how much now? 20,000. First person okay, second person okay. Third person is getting, for example, you take it as something like, take some extra, some 14,000. You take some 18,000, you take it. Is the person cannot withdraw. Why? Already 20,000, how much is gone? 5,000. 5,000 means only 15,000. Now he is trying to withdraw 18. It is a check bounce. Transaction fail. He is called what? Okay. Done. How much it is left out? Come on. 11,000. He is interested in getting what 12,000. 12,000. Check bounce. Now, one more last and final person. Finally, I will take it. How much is left out? Come on. 11,000. So he is getting 11,000 is writing. So he is called what Raj. So T6 dot. See that here I will say go to the pass. There I will write it. Tell me students. First what is coming? 1,000. 1,000. Already it was available here or not? Here I will come. Self dot W amount to be compared with what? ACC balance. If my self dot W amount is more than what? ACC balance, that customer will not get the withdraw. How do you write it? Tell me, mom. If self dot W amount greater than bank transaction dot class variable now dot what? ACC balance dot ACC balance. If that is the case, I'll try to write this message because it is a message is good. I'll take up this message. I'll try to write it. What I'm writing now, students, dear customer, I'll write it. That name I am printing. INR is is not available. Is not available. Not available in this account. In this account. Try for is nothing but what? Failed. I can say failed. Done. Understood? Next. After that, what are you writing? Else. I will write it. Else means what I will do, mom? Else means I will do it. As we done changes, here I need to do it. How do you do it, mom? Bank transaction dot ACC balance. Here you need not write a global keyword. Why? It's a class level variable. Is equal to dot what now? Self dot what? WAMT. Right? I say, dear customer, I say, is what? Dear customer, is available not necessary, is what? Withdrawn. That is nothing but what? Take INR. What is this now? Successful. Are you following me? Right. Take, write like this, I'll write it. Successful. SUCC is successful. Of what I will write it? This also. 1 minute I will write it. Here not invoice. What should I write it? Self dot WAMT. Here also I will write it what? Self dot what? AMT. Are you getting me? Right. Getting? Now, after that, what should I do? If you want to print any status of the person you want to print it, you can print it. What is this? I can say, now account balance, I will say. Now account balance, I will say. I'll write it. Now account balance. Now account balance is equal to, I can say this word. Here I am saying another customer is also coming. Okay. This part is going to come. And another thread. Like that, I have so many number of threads are there. I need to start them or not? Dispatch the threads. Online students. So 17th line doubt. Sanskar is having 17th line doubt. So 17th line doubt. What is the doubt, my dear students? 17th line. I mean 18th doubt. Okay. What is there in that? What is there in that? You mean 18. Okay. What is there in that? What is there in that? Your account balance, class level variable, calling with respect to what? Class name, dot your individual person cash, withdraw amount. He may be expecting CLS here. Can I use CLS? You cannot. CLS, imposition to write. Sanskar imposition you write. CLS is a formal parameter to be used in the same body. You cannot use in other part of it. My Indian constitution, I will open it. Python constitution, 6 p.m. Oops. Under that class, under that notes, types of methods, class level methods. Yes. HA. HA means CLS is one of the implicit object. CLS to be used as a first formal parameter. Since the CLS is the first parameter, so that it can access inside the corresponding class method only, but not possible to access other part of the program. Already written. My notes is so powerful. Wherever you go, my notes will follow you. That's why I'll show you everything so clearly. So dispatch the threads. Dispatch the threads. Okay, what is that? Something coming. So dispatch the threads. So Prashanti, I missed your OOPS class. So if you start OOPS in any of your batch, please let me know. I will join. Okay. So coming to that T6 dot, what again? Start. Start, I will say. So all of them, you just try to watch it. No need to use any global variable here. Let's start. Import threading, comma time. So here I'll save bank transactions, using what? Oops, example1.py. Mom? Okay, no issue. Synchronization అవసరం అంటాం. Save as. So, locking is important, correct? Good. I will take one lock also here. L is equal to what? CLS dot. L is equal to threading dot lock off. Lock off. Okay. Withdraw only, I will take care about that. Come on. Bank transaction dot. What is it? Dot L dot acquire bank transaction dot L dot release. Within the else, you see, if else parallel to, you need to write it. You know this technique, right? Release. Dot release. Good. So let us start doing that. So execute py and see the result of it. What is happening? Self dot amount is equal to amount. What is this? W amount. Not simply amount, W amount you need to write. Spelling mistake. So initial balance 6,000 cash successful. Rajesh successful. What is happening? ACC dot somewhere else. Where is it? CLS dot. CLS dot. What is that? Initial balance. CLS is not defined. Line number 25. Line number 25. Okay. What is this? Bank transaction. Bank transaction dot. Sanskar doubt that is. That's why I wrote it. Sanskar, because of your doubt, I got error. Now, because I was showing that concept and I forget to change. Now see, got your doubt. Now it is locked also. Why? Rajesh was successful and exception came. It was locked. No problem, Sanskar. So go to that. No problem, Sanskar. Go to that. Did you understand why locked? First transaction successful. Next time exception came and it is out of it. Python. What is this now? 6 p.m. Threads. So there I will go for executing py that code. What is this? This one. I'll take up this. So like that. 19,000 left out. Naresh also got 4,000 cash successful. 15,000 left out. 18,000 not available in this account. Right? Failed transaction. 4,000 successful. Account balance is called 11,000. Now 12,000 not available in this account. Now 11,000 cash is successful. Now account balance is 0 rupees. 0 rupees. That's all. So any banking application you work, simple coding, you will do wonders. Okay. Even failed students are working. BTech completed after 6 years, they are working. BTech for 4 years only. Completed after 6 years. Working. Why don't you work? Please practice the coding. Understood? Now this completes the threads. So tomorrow there is a class. I said already. Attend the session, guys. Go to the index. Go to the index. Here I show you. So here, what is this? Index I will show you. Index. So go to that index. You see purpose of thread-based application, definition of thread, module name, synchronization, locking implementation, everything. Okay, now. So I'll stop this class, and tomorrow class 7 AM to 9 AM, some problem solving approaches. So tomorrow don't miss it. And the day after tomorrow, Monday, I'll introduce network programming, that is 2 days, and the regular expressions, that is 3 days. That is our topic. You want me to start networking first or regular expressions first? Which one? Networking. Okay. Whatever you say, I will start. Monday, what? Network programming. Then I'll go for regular expression. That will be our class. Monday, Tuesday, Wednesday, Thursday, Friday. Friday is the last. And 22nd, 11 AM, new batch is starting. New batch. Python new batch is starting. Any friends are there? You tell them. Online and offline, 22nd, coming Thursday. New batch is starting. Any friends are there? Tell them. Okay. I'll stop the class. And Monday class, I'll go for regular expression. Tomorrow, 7 AM to 9 AM, problem solving approach. Thank you. All the best.